This problem's nice because it kind of brings in trigonometry with infinite series. So we have to evaluate this. So it must evaluate to something simple. Let's just focus our attention on this. We want to consider this an infinite geometric series. And like, what's our common ratio? Well, we're timesing by cosine squared. So our common ratio is cosine squared. Okay. So let's see. So now I know this infinite geometric series can be equal to, your first term divided by 1 minus the common ratio. And this would be, so 1 over 1 minus cosine squared. I should say this, remember, this formula only works when, the absolute value of r is less than 1. So this wouldn't work when theta is equal to anything that makes cosine squared equal to 1, which would be pi, any multiple of pi, basically. So I should say that, but we'll just leave that aside as a side note. All right, so now I've got that 5 sine squared, and if I multiply it by 1 minus cosine squared, or 1 over 1 minus cosine squared. So again, just a reminder, like all of this I'm saying is equal to this according to my formula. All right, and if I distribute, I get 5 sine squared over 1 minus cosine squared, but of course 1 minus cosine squared, remember, is also known as sine squared. So I get 5. Again, the assumption is theta, theta can't be pi, or it's just a little side note. The answer is 5, but like as a side note, theta cannot be any multiple of pi, because if that happens, then r is 1, and then this formula makes no sense.